Hi there, I'm Rajshree Chabukswar, Intel Fellow leading hardware software co-design on client platforms, and welcome to episode 2 of Architecture All Access Season 3. Today, I'm thrilled to be discussing Meteor Lake's 3D performance hybrid architecture and enhancements to Intel Thread Director technology, helping operating system make optimal scheduling decisions. Over past 2 decades, I have led software optimization efforts at Intel, driving power and responsiveness differentiation with ISVs, OEMs, and OSVs. Recently, I have co-designed Intel's Thread Director technology with our hardware architects using software feedback, and today we continue this work for Meteor Lake family of processors. I'm pleased to introduce to you our new 3D performance hybrid architecture and how we harness its full potential. Our usage of computers has grown, and so have the computing resources needed to meet increasingly demanding task and multitasking workflows. As this happens, CPU compute efficiency becomes paramount in designing and implementing processors. To maintain this multi-core performance benefit, we have embraced a new technology in which we combine our efficient E-cores to provide multi-threaded performance under given power envelope and our powerful P-cores for peak performance. To illustrate the changing nature of workloads and core types, let's use an analogy. Imagine you own a delivery company initially focused on transporting large furniture, and now your fleet of large vans are consistently filled with deliveries. However, as the business grows, it starts to diversify, and you also start servicing smaller deliveries that barely utilize the van capacity. Instead of buying large vans to fulfill your demand, you decide to invest in smaller vehicles that can handle smaller deliveries along with your large orders. This hybrid approach allows you to adapt to evolving demands efficiently. In context of chip architecture, this means incorporating different types of cores to handle varying computing demands. We implemented this approach first with Lake Field, targeting low thermal design points. Alder Lake followed with performance hybrid architecture featuring E-cores for area-efficient multi-threaded performance and larger P-cores for peak single-threaded performance. With this architecture, we also created Intel Thread Director technology to orchestrate operating systems usage of this new design. Meteor Lake now takes this hybrid architecture concept to the next level. By the way, if you haven't watched Tim's Meteor Lake architecture overview, I highly recommend you take a look. Link to that video is in description below. In the episode, Tim describes 4 tiles that make up Meteor Lake: compute tile, graphics tile, SoC tile, and I/O tile. Let me talk about the major improvements we have made with our hybrid architecture and associated Intel Thread Director technology in Meteor Lake. First, we built disaggregated compute tile using Crestmont E-cores with increased IPC and additional improvements for CPU-based AI, as well as new Redwood Cove P-cores with improved power efficiency from design and process. Next, we added low power island that includes set of low power E-cores directly into SoC tile. Partitioning these low power E-cores and functions such as memory control, media, NPU away from compute tile lets them run much more efficiently under separate power rail. For our delivery company analogy, imagine this as having specially outfitted even smaller vehicles that can handle deliveries separate from your existing operations. In Meteor Lake, this means that during tasks like video playback or very low usage IT load, the low power island can handle the workload while compute tile remains undisturbed or even turned off. Let's take a look at this demonstration. You can see that while doing media playback, a task that is very low CPU intensive, Meteor Lake is able to run that task on low power E-cores. That's those 2 last threads that you see at the bottom of the task manager graph in the summary view. This allows Meteor Lake to achieve a very low power consumption state while doing this type of low compute intensive task. This is what we call our new 3D performance hybrid architecture, which enables a new tier of compute power efficiency. Now, ensuring right workloads are assigned to appropriate cores is a fundamental part of hybrid architecture. This is where our enhanced version of Intel Thread Director technology comes into play. Built into hardware, Intel Thread Director provides guidance to operating system for optimal scheduling decisions to efficiently manage workload distribution and optimize performance across different workload types. The way Thread Director works is the operating system initializes the space in the memory when it sees hybrid architecture. First part of Thread Director is instruction classification that runs in the cores. This essentially categorizes the current work into 4 different classes. The second part is enhanced hardware feedback table, which indicates what is the most performant or efficient core to run the task on. Hardware exposes both performant and efficient core information to OS, so OS can pick relevant cores based on if the system is running on AC or DC power. The OS scheduler uses hardware information along with other pieces of intelligence such as priority, quality of service that it already has to make scheduling decisions. Thread Director is now smarter than previous generations, supporting both compute and SoC tiles and incorporating more advanced feedback from efficiency cores, significantly improving workload classification and power optimizations. Let's provide an example on how this works. High priority application in user's foreground that needs responsiveness, such as games, will be executed as quickly as possible on P-cores to ensure that user gets that snappy experience. Because the compute tile is already on, we can schedule new background tasks like audio playback on the compute tile E-cores. When the high utilization workload completes, we are then able to migrate the low utilization tasks to low power E-cores on the SoC tile to maximize energy efficiency if the task is able to fit in there. Thread Director automatically updates the guidance to the OS accordingly. When a new high utilization workload begins, Thread Director then recommends OS to assign that task to P-cores. In conclusion, Meteor Lake's 3D performance hybrid architecture combined with a smarter Thread Director helps Meteor Lake achieve its power efficiency goals while delivering on the responsiveness the user requires. Of course, we collaborate heavily with operating system vendors like Microsoft Windows to make sure this hardware-guided scheduling technology is well leveraged. Thank you for joining me today for Architecture All Access, Meteor Lake 3D Performance Hybrid Architecture and Intel Thread Director. Keep an eye out for upcoming episodes where you'll learn more about why Meteor Lake is our most significant client SoC architecture shift in 40 years. Thank you for listening.